Why did the Apple car, a project codenamed Titan, end in a $10 billion scrap heap? Today, we're analyzing the most expensive failure in the history of Silicon Valley, the Apple Autonomous Vehicle project, to see exactly where the math, the engineering, and the corporate vision fell apart. By the end of this breakdown, you will understand the complexity ceiling, the exact point where software intelligence fails to overcome mechanical reality, and why Apple chose to walk away from $10 billion rather than risk their brand on a single catastrophic failure. Most people believe that Apple simply couldn't figure out how to build a car. They're wrong. They didn't fail at building a car. They failed at answering a single fundamental question: what is an Apple car actually for? For 10 years, Apple poured billions into a project that never saw a public road. We're going to look at the blueprints, the leadership shifts, and the fatal engineering compromises that led to the death of the ultimate mobile device. If you are fascinated by the hidden friction between big tech and heavy industry, you are in the right place. Subscribe, because every failed megaproject leaves a blueprint for the future, and we're here to decode it. I've always been fascinated by how a company that perfected the smartphone can struggle so profoundly with a machine that has 4 wheels and a battery. But as any structural engineer will tell you, a phone is a controlled environment. A road is chaos. Once you understand the physics of autonomy and the internal politics of Cupertino, the disaster of Project Titan starts to make total sense. To understand the collapse, we have to look at the simple engineering foundation of an electric vehicle. At its core, an EV is a skateboard, a flat chassis containing the batteries with motors on the axles and a cabin on top. It is, in theory, simpler than an internal combustion engine. But Apple didn't want to build an EV. They wanted to build a robot on wheels. They aimed for level 5 autonomy, which means a car with no steering wheel and no pedals. This is where the math falls apart. Imagine a vehicle where the occupants sit facing each other, like a private jet or a lounge. In the early design phases, which some insiders called the Breadloaf, there was no front or back. It was a glass-heavy, minimalist pod. But here is a shocking fact that rarely gets mentioned. At its peak, Apple was spending over $1 billion a year on research and development for a product that didn't have a final prototype. That is roughly $2.7 million every single day for a decade spent on a ghost. Imagine a hairline fracture in a billion-dollar foundation. For Project Titan, that fracture was the definition of success. Watch what happens to the internal rebar of a project when the goalposts move every 12 months. Screen visuals would show a hyper-realistic blueprint of a car chassis, but as we look closer, the steering column disappears, then reappears, then turns into a joystick. This is not how you build a vehicle. This is how you build a fever dream. From a physics standpoint, Apple was trying to solve 2 of the hardest problems in engineering simultaneously: revolutionary vehicle architecture and perfect self-driving software. According to internal reports, the team was constantly pivoting between these 2 goals. This created a massive retention spike in engineering talent, not of staying, but of leaving. The engineers ignored the geological reports of the automotive industry. In the car world, you don't iterate in the cloud, you iterate in steel and rubber. The engineers wanted to use LiDAR sensors that were flush with the bodywork, maintaining that sleek Apple aesthetic. But LiDAR requires specific angles and unobstructed views to map the world in 3 dimensions. Every time the design team wanted the car to look more Apple, the engineering team had to explain why the physics of light and reflection wouldn't allow it. Here's what the investigation into Project Titan revealed. The most terrifying detail the inspectors and board members realized during a test drive in 2021 was that the software still struggled with basic navigation in suburban environments. The car, a modified Lexus SUV fitted with Apple's tech, nearly struck a jogger because the software categorized the person as a stationary object for a split second too long. Most people believe these structures, these massive corporate projects, are destroyed by outside competition. They wasn't. They were destroyed by human arrogance. The belief was that because Apple could design a custom silicon chip, they could design a system that could predict human behavior on a highway. Let's look at the actual blueprints of the leadership changes. First, you had Zadesky, who wanted a car that could actually be manufactured. Then, Bob Mansfield took over and said, "No, we're a software company. Let's just build the brain." Then Doug Field came from Tesla and tried to bridge the gap, only to leave for Ford. Finally, Kevin Lynch, the man behind the Apple Watch, was tasked with finishing a project that had no clear start. This is where the math falls apart. You cannot build a bridge if the lead architect changes the length of the span every time a new stone is laid. Here's what most people get wrong about this disaster. The media claimed the Apple car failed because Apple couldn't find a manufacturing partner like Hyundai or Nissan. The truth is much more sobering. Apple didn't want a partner, they wanted a ghost manufacturer. They wanted a company to build the car the way Foxconn builds the iPhone, taking zero credit and having zero input on the design. But car companies aren't Foxconn. They have their own brands, their own legacies, and their own massive factories to protect. When Apple approached BMW and Mercedes, they were essentially asking these titans of industry to build their own executioner. The negotiations failed not because of money, but because of ego. Imagine £1 billion of pressure, not from water, but from the expectation of the stock market. Every year that passed without an Apple car, the pressure on the engineering team increased. They began to take shortcuts in the software simulations. This created a myth-busting moment for the industry. People assume that more data always leads to better AI, but the autopsy of the Apple car showed that Apple had plenty of data. What they lacked was edge case experience. A Tesla has billions of miles of real-world road data. Apple's fleet of test cars had only a few 100,000. In the world of machine learning, that is the difference between a high schooler and a PhD. The concrete of their AI foundation didn't fail because it was cheap. It failed because it was poured too fast into a mold that was constantly changing shape. This matters today because if you look at modern infrastructure and the current push for AI everything, many companies are making this exact same structural compromise. They are assuming that general intelligence can solve specialized mechanical problems. But a car is not a smartphone. If your phone freezes, you hard reboot it. If your car's operating system freezes at 60 miles per hour, people die. The liability and the physics of kinetic energy are things that Silicon Valley has traditionally ignored, but they are the very things that brought Project Titan to its knees. Most people don't realize the physics at play when we talk about Level 5 autonomy. To achieve it, you need the car to be better than a human in every possible weather condition, from a blinding snowstorm in Michigan to a dust storm in Arizona. Apple's monocell battery technology was a legitimate breakthrough. It promised to pack more active material into a smaller space, giving the car incredible range. But range doesn't matter if the car doesn't know how to turn left at a busy intersection without a traffic light. The engineering reasoning eventually led to a hard truth. To make the car safe, they had to add the steering wheel back. And once they added the steering wheel and the pedals back, the Apple car just looked like a very expensive Tesla. The hubris was thinking they could skip the evolution of driving and go straight to the finish line. So the reason this $10 billion project collapsed after a decade comes down to three things: a lack of a singular, unchanging vision from leadership, an obsession with Level 5 autonomy that ignored the reality of current sensor technology, and a fundamental failure to respect the complexity of the global automotive supply chain. They spent 10 years trying to build a revolution, only to realize that the world just wanted a really good car. But here's the most fascinating detail the final reports revealed. Even though the car is dead, the technology isn't. The work done on Project Titan is currently being integrated into the Apple Vision Pro and the next generation of Apple's AI. They didn't just throw $10 billion away, they paid for a 10-year masterclass in robotics and spatial computing. However, as a standalone infrastructure project, the Apple Car will go down in history alongside the Spruce Goose, a marvel of engineering that was too ambitious for the reality of its time. If you look at the landscape of 2026 and beyond, the lesson is clear. Software cannot override the laws of motion, and $1 billion can't buy a shortcut through a decade of real-world testing. The lateral pressure of investor expectations pushed the project past its snapping point. The foundation was built on the shifting sands of corporate strategy rather than the solid bedrock of a defined product. If you learned something new from this investigation into the blueprints of failure, subscribe. Next, we're breaking down why China's perfect megacity is completely abandoned, and the blueprint error in their high-speed rail integration might surprise you. We will look at how a $50 billion city became a ghost town in less than 3 years. Every collapsed structure, whether it's made of concrete or code, leaves a blueprint, and we're here to decode it. The autopsy of the Apple Car is officially closed, but the era of AI-driven machine is just beginning. The question is, who will have the humility to build it one wheel at a time?